Hi everybody, welcome to our lesson 5.4, and we are looking today at the normal distribution or normal distribution curves, which are also sometimes called bell curves in statistics. And so this lesson is just going to look at one way that data can be spread out, and it's spread out in the shape of a bell or a normal distribution curve. So if you've got your notes in front of you, 5.4, we're going to go ahead and get started. So let's talk a little bit about how data can be distributed. We've seen some frequency graphs already, or histograms, polygons, where we graph, some intervals on the bottom representing the data and the frequency at the top. And depending on what that graph looks like, it could be spread in different ways. So for example, if we look at this yellow bar graph in front of us, I can see here that if each one of my rectangles or bars represents data, okay, I can see that the majority of the data is right in here. Okay, that represents most of the data. I have the highest frequencies there. So this data is sort of spread more to the left, or spread more to the right. So data, okay, is more to the right. Or in other words, I find most of the data near the right-hand side of this graph, so at higher values of x. Okay, the purple graph here, I see that the majority of my data is right in here. Okay, this data is sort of pushed over to the left, and so I can say that this data is more to the left. Okay, and if you look at the blue graph, it's pretty random. It's sort of all over the place, isn't it? On the left-hand side, I've got some pretty big frequencies, but also over here on the right-hand side, I have some as well. I've got some low frequencies on the left as well as on the right, and in the middle too. So I could say that this data is randomly distributed. So there's lots of different ways that data can be spread out. We're going to look from here on in at one particular way that data can be spread out. And when we look at the graph, it forms what we call a bell curve. Let's have a look. If you look down below at this yellow graph, we can see that the data is centered really around the middle. Okay, there's a concentration of data. The highest frequencies tend to be right in the middle, and then they decrease as I go to the left, and they decrease as I go to the right. This is called a bell curve because it forms the shape of a bell. Think about what a bell looks like. It looks like this. There's my little bell. So if I were to take my line and just sort of outline the shape of this graph, it resembles the shape of a bell, just like that. Okay, it's a bell, we call that a bell curve. And the normal distribution is just a fancy way to say the bell curve. When you see data that looks just like this curve that you see here, where the majority of the data is in the center, and then as we move out to the sides, we see that there are lower and lower frequencies. Okay, normal distribution, this is just one way that data can be distributed. And we see it in a lot of different examples. So for example, often class marks are, there'll be a mean for the class, and most people sort of fall in, let's say, a 75% range. A few people might get 100%, and just a few people might get really low marks. Age is like this too. The majority of people are in their middle ages in the world. Very few people are over 100 years old, and we might say there's a smaller number of infants compared with the rest of the population. So lots of data, when graphed, ends up looking like this bell curve, and we say that type of data is normally distributed. Okay, so some data sets form a curve in the shape of a bell when graphed. This is called a bell curve. It's symmetrical, which means that I could divide it right down the middle here. Okay, and I see that the left-hand side is a mirror image, or very close to a mirror image of the right-hand side. So there's symmetry. data that is spread out this way, we call that normally distributed data, and often measurements of living things. So I just gave some examples of people and their heights, or lifespans, ages, mass, very often follow this type of distribution. It looks like a bell curve when they're graphed. A couple of things I want to recognize about this bell curve. If you're looking at it, because it's symmetrical, in other words, I could divide it right down the middle. One thing I want to recognize is that all of these rectangles, all added together, represent all of my data. Okay, so the shaded area, okay, under the bell curve here, so all the rectangles, represents all of my data. In other words, 100%, okay, of my data. So that means that under the curve, that's 100% of my data. If I were to add up all of those frequencies, okay, they should give me the total number of data values that I had in my data set. So that's all of my data is accounted for here, which means that if this is symmetrical, 50% of my data lies to the left of the center of this curve. Okay, so 50% of my data here is to the left, and the other 50% of my data is to the right of the middle. And I can say that's true because this bell curve is symmetrical. So if I divide it in two, half of it is on the left and half of it is on the right. Let's go ahead and talk about some important things that we need to know about this normal distribution curve or this bell curve. So there's some things that are always true about a bell curve or data that's normally distributed. First of all, there's a line of symmetry right at the center. Okay, here's the line of symmetry right here. Sorry, the green line. Okay, in your that line that's right in the center there. Okay, so there's the line of symmetry. The center, that line of symmetry, represents the average. Okay, this is the average. And when we talk about bell curves and normal distributed data, instead of using X, okay, with the little bar over top of it, we use a different symbol called mu. Okay, mu. So X is now this mu, okay? And mu is, let me draw that again. That it looks like the letter U with a bit of a long tail in the front, okay? That's the letter mu. And the mu is the average or the mean. Okay, and the mean is right at the center there. A mean, okay, median and the mode are close to being the same number. They're close to being equal with data that's normally distributed. Simply because 50% of my data lies on one side of the mean and the other half lies on the other side, on the right-hand side of the mean. It turns out that my median and my mean are very, very close, if not the same value, okay, which is sometimes not always true with other types of spread out data. But in this case, normal distribution leads to having a mean, a median, and a mode that are close to being equal. So the most common number is going to be very, very close to the mean here as well, because it has the highest frequency. All of these data values under the curve represent 100% of the data, which means we can split it in half and say 50% is to the left and 50% is to the right. We can also break this curve apart, and there are some things that are always going to be true about it. So let's go ahead and look at this curve here that you're given. And in class, we're actually going to draw ourselves out a curve like this and add it to our data booklet so that we don't have to memorize all of these percentages, okay? But with a bell curve, okay, we've already said that 50% of my data lies to the left, 50% of it lies to the right. We can also break this curve up in terms of standard deviations. So in the center of my curve, I'm going to put the mean. So I'm going to draw a line of symmetry right down the center, and that value, okay, represents the mean. It has the highest frequency. Okay, there's my average for my data. And then if I move out 1 standard deviation, so the mean plus 1, I could draw a line right there. Okay, and I could move 1 standard deviation below the mean right here. Okay, so that the difference between here is just equal to 1 standard deviation. Okay, and the same thing is true over here. So this is just, we're just going out by 1 standard deviation on either side of the mean. And something that's true is that 68% of my data will be in between 1 standard deviation of the mean. So let's write that down over to the side. Okay, so this 68% means that 68%, okay, of all the data, okay, is within 1 standard deviation of the mean. So 1 standard deviation, which is, we use that little sigma to represent a standard deviation, okay, of the mean. Okay, this is always true for normal distributed data. So any bell curve that you're looking at, it's always going to be true to say that 68% of that data falls within 1 standard deviation. I can go out 1 more standard deviation. Okay, so now I'm 2 standard deviations away from the mean. And if I do the same thing in the other direction, okay, and I were to, so I'm going to just put a line there to represent where that is on my curve here. 95% of the data, okay, that's most of our data, is within 2 standard deviations of the mean. Okay, so 95% of the data is within 2 of those standard deviations. Okay, so 2 standard deviations of the mean. All right. Finally, we said that our bell curve represents 100% of the data. Well, if I move out 1 more standard deviation, now I'm at 3 standard deviations away from the mean, and I can look on both ends, so plus and minus 3 standard deviations. So again, let's just go out 1 more standard deviation here, and put a line, okay? And you've already got the line on your graph, I'm just showing you where it is, okay? So if I move out 1 more standard deviation here, okay, now compared to the mean, I'm 1, 2, 3 standard deviations away from the mean. And if I go out that many standard deviations, that's almost all of my data. That's almost 100% of my data. So 99.7% of my data, I'll just write this one over here. Okay, 99.7% of the data is within 3 standard deviations of the mean. Okay, which means that there's still a little bit of data that is outside of 3 standard deviations. So this small little area right here, we'll break this down in a minute. Okay, there's still my bell curve does continue, okay, just past 3 standard deviations. So there is a very small amount of data under that part of the curve, okay? It's very, very small. It's going to be, well, I can see that all I'm missing here is 0.3%. If to get to 100%. So half of that is on this side. So that's 0.15%. Okay, of the data is outside of 3 standard deviations. And on the other side, 0.15% of the data is above 3 standard deviations. So that's the little small area under that part of the curve. Okay, it's very, very small. So there's very few data values that are that far from the mean. If I know that, if I look at the red section for a minute, okay, so what we're saying here is that this red section here, from the mean minus 1 standard deviation to the mean plus 1 standard deviation, so from here to here, okay, if that represents 68% of the data, I could divide that in half and say that this side represents 34% of the data, and this side, so above 1 standard deviation above the mean, represents 34% of the data, because 34 plus 34 gives me 68. So I'm just dividing that by 2. Okay. It's also then true to say, if I look at the green section here, okay, on either side, so if I look at 2 standard deviations above the mean, Okay, so from here to here, okay, that's half of 95%. And then over here would be the other half of 95%. So I can figure out what that is. Okay, and half of 90 is 45, and half of 5% is 2.5. So I would get 47.5% of the data is here, and 47.5% of the data is 2 standard deviations below the mean. And if I subtract 34 from 47.5, what I get here is 13.5. Okay, so 13.5 represents this little area here. Okay, and 13.5 represents this little area over here. 13.5%. Okay, so we're just breaking it down. If we go outside to 3 standard deviations, the difference between 95% and 99.7% is 4.7%. So each of these blue regions here is just half of that. So we get here, okay, this little area right here represents 2.35% of the data. And you could always figure this out yourself, but we're actually going to write this down in class and we're going to use it so you don't have to memorize all of this. Okay. So 2.35% represents between 2 and 3 standard deviations from the mean. And then there's a little tiny bit of data that's outside of 3 standard deviations. And how much of it is there? Only 0.15% of the data, okay, is outside 3 standard deviations. If you add all these percentages up, we're going to get 100%, and that represents all of our data. So using this curve now, let's go ahead and answer some questions, okay, about any data that's normally distributed. So what percentage of the data values are below or equal to the mean? Well, what is that asking us? If I just quickly draw myself a bell curve, okay, or I look at the one up top, I know the mean is right in the center. There's my line of symmetry. So how much data would be either equal to the mean or below it? Well, that would represent all the data, right? This going below is going to the left. So that would represent all the data to the left of the mean, and that would be equal to half of my data. So 50%, okay, of my data is below or equal to the mean. All right, what percentage of the data are above the mean or equal to the mean? Well, that's the other half here, isn't it? If you think about it, there's my bell curve, right? There's my mean in the center. Above the mean or equal to the mean would be anybody that's to the right of the mean. Okay, so any of these data values that would fall under this section of the curve would be above or equal to the mean, and so that's the other 50% of my data. All right, what percentage of data values are within 1 standard deviation of the mean? Let's go ahead and look at our graph up top for a minute. Well, where is 1 standard deviation of the mean? Well, it's either if I'm 1 standard deviation above the mean, it's right here, okay, in the red. And if I'm 1 standard deviation below the mean, I'm right there. So what that means, within 1 standard deviation, okay, that means between okay, the mean minus 1 standard deviation, okay, and between the mean plus 1 standard deviation. That's what within a standard deviation means. Okay, so on my graph, right, there's mu minus 1, there's mu plus 1. So I'm asking myself, okay, what percentage of data is within 1 standard deviation? And if you look at your graph, it is 68%. Okay, 34% is above the mean, 1 standard deviation above. The other 34% is 1 standard deviation below. And so 68%, okay, of the data is within 1 standard deviation. That's true for all data sets that are normally distributed. Okay, it doesn't even matter what the mean is. They all still have the same shape, and the breakdown is the same for all of them. So we can use these percentages for any kind of data that's normally distributed. Let's do a real example here with some real values. So IQ scores were measured, let's say for a population of people, maybe it's the people that live in Canada or people that live in Vancouver. And IQ scores are usually normally distributed, which means that when we go ahead and make a frequency graph for them, they usually look like this as a bell curve. This example below shows the IQ scores for a population of people that has a normal distribution. So first thing I'm going to do is look at this bell curve, and I'm just going to start to make some markings on the bell curve. So the first thing I see here is that the middle of this bell curve is right here at 100. So there is my mean. Okay, that's my average or my mean IQ score. So it's equal to 100. So on average, most people have an IQ score of 100. Okay, some people have an IQ score that is 1 standard deviation above the mean. Okay, and I can see that that would be at 115. So 115 represents the average plus 1 standard deviation. Okay, so if I come out 1 standard deviation, I get to 115. If I go back 1 standard deviation, so I get to 85. So 85 represents the mean minus 1 standard deviation. Okay, so right away I can start to make some sense of this graph. I see that the next value, okay, 115, the next value after that is 130. Well, that's another 15. So there's another standard deviation away from the mean. So 130 right here. Okay, and 70, those represent 2 standard deviations away from the mean. So 130 is the mean plus 2 standard deviations, and 70 is the mean minus 2 standard deviations because it's below the mean. And finally, 145 is the last one. And that one represents the mean plus 3 standard deviations. And 55 here represents the mean minus 3 standard deviations. Okay, so let's answer some questions. What is the mean IQ? Well, the mean IQ is the one that's right in the center, and it's equal to 100. So the mean is 100. What is the standard deviation? All right, well, you could look at your graph, the bell curve, and figure it out quite quickly. I can see that if I go out to 1 standard deviation, I'm at 115. So the difference between the mean and 1 standard deviation above the mean is 15. Okay, so it's equal to 15. And how did I figure it out? Well, I could look at my graph, or I could figure it out mathematically, right? I know that the mean plus 1 is equal to 115. Okay, and I know that the mean is equal to 100. So if I try to figure out what the mean is there, it's going to be equal to 15. All right, so 1 standard deviation then. Sorry. I apologize, I forgot my sigma sign there. So 1 standard deviation. So that's 100, right? Plus 1 standard deviation is equal to 115. So if I wanted to isolate what is 1 standard deviation, I'll just move that 100 over to this side. So 115 minus 100 is equal to 15. Okay, but you could also just look at your graph and see the difference between the mean and 1 standard deviation. The difference is 15. How many people have an IQ score between 70 and 130? Well, let's have a look. Where's 70? Right here. Okay, where's 130? Right here. So between 70 and 130 represents, let's see, that's within 2 standard deviations of the mean. Okay, so that is going to be within 2 standard deviations of the mean, because 70 is at the mean minus 2 standard deviations, and 130 is at the mean plus 2 standard deviations. So we can go back to thinking about our breakdown, okay? And 95% of the data is within 2 standard deviations of the mean. This is always true for all data that's normally distributed. So 95%, okay, of the data falls within 2 standard deviations. So that is always true. Okay, this represents 95% right here. Okay, a person has an IQ score of 145. Is this common? Well, let's find that. On the bell curve, 145 is right here. That is 3 standard deviations away from the mean. Okay, I can see that. And so 3 standard deviations of the mean is pretty far from the mean. And if you look at it, the number of people who have an IQ score of 145 are represented by the shaded area under that part of the curve. That's a very, very small number of people, okay, compared to 100, for example, where there's lots and lots of people. The frequency of people here, if I came over here for a minute, the frequency would be quite high. Okay, the frequency for 145, if I came over here, would be quite low. So very few people have IQ of 145. That's quite a high IQ score. So the answer is no, this is not common. Okay, how many standard deviations away from the mean is 145? Well, by looking at my graph, I can see that it is 3 standard deviations, okay, above the mean. So 145 represents the mean plus 3 standard deviations, which makes sense, right? Because the mean's 100, and if we add that to 3 times 15, I get 100. 3 times 15 is 45, so I get 145. Okay. So this is quite far from the mean, right? Then the area under there, under that part of the curve would be extremely small, not common. Let's do one more example here for ourselves, and then we're going to stop. So here's an example. 95% of people at a school are between 1.1 meters and 1.7 meters tall. The height is normally distributed, so I have a bell curve. Sketch the normal curve using only this information. So here's what I have. 95% of people are between 1.1 and 1.7 meters tall. I want you to start to be familiar with this breakdown right here in your notes. Okay, so when you see 95% of the data, okay, it's always true that 95% of the data are between, let's just see, 2 standard deviations from the mean. So 95% of the data represents all this data right here. Okay, it's a lot of our data, 95%. So 95% of people, okay, will be within 2 standard deviations of the mean. If I look at my question for a minute, okay, that tells me that 1.1 and 1.7 are 2 standard deviations away from the mean. So let's go ahead and write that down. Okay, so in a normal distribution, 95% of the data, okay, is within 2 standard deviations from the mean mu. Okay, so that means that my lower value, 1.1 meter, okay, my upper value must be within 2 standard deviations of the mean. So this one, 1.1, must be the lower value, so that must be the mean minus 2 standard deviations. And 1.7 must be the mean plus 2 standard deviations. So with this information alone, I can go right ahead and start my bell curve. Okay, so let's draw my bell curve, or my normal distribution curve. Okay, I'm going to start with putting a line here, straight line there, okay, and we'll go ahead and draw my mean right in the center. Okay, there's my mean, and I'm going to try to draw a symmetrical bell curve on either side. So let me make this a little bit bigger. Okay, and I'm going to come down like that, okay, on one side, and try to come down, making it look as symmetrical as I can. So I just should come right down to the bottom there. Okay, and there is my bell curve. And now let's go ahead and separate this curve out by standard deviations. So let's take and we're going to go out to 1 standard deviation right here. So there will be the mean plus 1 standard deviation. And I can go ahead and I'm just going to break that curve right up like this. And I'm going to try to go back an equal distance here so that this is just representing 1 standard deviation. Okay, 1 standard deviation below the mean will be the mean minus 1 standard deviation, and I can break the graph up like that. Okay, and then I'm going to go ahead and break it up one more time over here. So again, try to make that an equal distance to represent only 1 standard deviation. And there's the mean plus 2 standard deviations. And on the other side, same thing. Okay, there's the mean minus 2 standard deviations. And finally, let's go out one more. Okay, one more standard deviation. And there's the mean plus 3. Okay, and one more here to the left. And there's the mean minus 3 standard deviations. Okay, so there's a normal curve sketch. Now I can go ahead and put those two values that I have right here, okay, into on my curve. So on the bottom, the mean minus 2 standard deviations right here is 1.1 meters. Okay, and above 2 standard deviations above is 1.7 meters. And I can go ahead and say, there we go. I've labeled those on my curve. So that's what I've been given. Now we can go ahead and figure out where the mean is, okay, what the standard deviation is, and fill in all the rest. So let's go ahead and look at the questions that you have below. It says find the mean and find the standard deviation. Let's start with the mean. Okay, so let's start with the mean. I know that the mean is going to be exactly in between 1.1 meters and 1.7 meters. It's got to be right in between those two, right? Because it's right in the center of this curve. So I know that the mean is exactly between 1.1, okay, 1.1 and 1.7 meters. I know it's right in between there. So let's go ahead and find it. Let's just take the average of those. So I'm going to say the mean is going to be equal to 1.1 plus 1.7 divided by 2 because I want to go right halfway in between them. Okay, well 1.1 plus 1.7 is 2.8 divided by 2 is 1.4 meters. There's the mean, okay, right directly in between them. All right, so going back to my curve for a minute, I could go ahead and draw that in. So the mean is at 1.4 meters. Okay. What's the standard deviation? Well, let's figure out the standard deviation. Okay. Sigma, or standard deviation. Well, I know that the difference, I know that I could use either 1.1 or 1.7. Let's use the upper one. So I know that 1.7 meters, okay, is equal to the mean plus 2 standard deviations. That's what I was given. I know that's true. So let's go ahead and figure out then what is the standard deviation equal to. Okay, so 1.7 meters is equal to the mean, which is 1.4 meters, plus 2 standard deviations. So let's move that 1.4 meters to the other side. Let's subtract it so that we get, okay, 1.7 minus 1.4 is equal to 2 standard deviations. That's equal to 0.3. So 0.3 is equal to 2 standard deviations. And I just want to know what is 1 standard deviation. So if I divide by 2, okay, I get that the mean, or standard deviation, sorry, is equal to half of 0.3, which is going to be 0.15. 0.15 meters. Okay, so there is my standard deviation. It's equal to 0.15 meters. Again, I could go back and I could put that now into my graph. Okay, so every single standard deviation away from the mean is equal to 0.15 meters above the mean. So let's go back here for a minute and fill that in. Okay, so sigma, standard deviation, is equal to 0.15 meters. So if I looked at 1 standard deviation above the mean right here, okay, that would be 1.4 plus 0.15, so that will be 1.55 meters. Okay, we could just double check that if I added 0.15 again, that would give me 1.7, and it does. Okay, so this right here is equal to 0.15 meters. Okay, and again, if I go 3 standard deviations, okay, right here, that will be 1.4 plus 3 standard deviations. Standard deviation is 0.15, so I get 1.4 plus 0.45, and so 3 standard deviations away from the mean. I could figure that one out too. It's equal to 1.85 meters. Okay, and again, you could go in the opposite direction here too and fill this one out. So 1 standard deviation below the mean will be the mean minus 0.15, which is 1.25 meters. Okay, so I can continue and I could fill this whole thing in if I wanted to, but let's go ahead and just finish answering those questions. So it says find 1 standard deviation above the mean. How tall am I? Okay, well, my height will be the mean. Above tells me to figure out what is the mean plus 1 standard deviation. All right, so I say, well, my height will be the mean plus 1 standard deviation, so it's 1.4 meters plus 1 standard deviation, which is 0.15 meters. And my answer is going to be 1.55 meters. That's my height. All right, my friend is 1.85 meters tall. Without looking at the curve, how far is this from the mean? All right, let's think about that for a second. So this person's height is equal to 1.85 meters. Okay, let's find the difference, or in other words, the deviation from the mean. Remember that you can find the deviation for one single value, and the difference between this, my friend's height, and the mean would be if I take her height. Okay, so the difference is equal to her height minus, actually I should really be following my formulas for a minute. So it should be her height minus the mean. So it's x minus the average, or in this case, the mean. So 1.85 meters minus 1.4 meters. And so I get 0.45 meters. Okay, so she's 0.45 meters above the mean. That's her difference. Okay, how many standard deviations is that from the mean? Okay, so to find the number of standard deviations, well, just think about it. It's going to be how many 0.15s can I fit into that number? Okay, and it's going to turn out to be 3, but I could also just check it mathematically. Okay, because if I take the difference between her and the mean, and I divide it by 1 standard deviation, that will give me how many standard deviations she is away from the mean. So 0.45 meters is for the difference. Divide that by the value of a standard deviation, which is 0.15. Okay, and I get 0.45 divided by 15, 0.45 divided by 0.15 is 3. Okay, so she is 3 standard deviations above the mean. Okay, so above mu. So that's going to be mu plus 3 standard deviations. And again, if you had used the curve, okay, if we'd already filled in our values at the bottom of our curve, and she's 1.85, if I look at my curve for a second, okay, well, she's right here. Okay, at 1.85, which is 3 standard deviations above the mean. All right, I'm going to stop right there, folks. I think that's enough in terms of examples. There is one more question in our notes. We're just going to skip it for now. Okay, I'd like to get you trying some yourself, and I want to keep this video somewhat short for you. So I'd like you to go ahead and do your worksheet 5.4 in your worksheet package on normal distribution. Check your answers to ensure that you're doing it correctly, and use the breakdown in your notes. So refer to this chart that we have in our notes here that shows the percentage breakdowns, because you will need to use those. Okay, thanks for joining me today, and good luck. Bye for now.